Welcome everybody, this is 5.2 Graphing Basics. So last time we talked about key features of parabolas, and today we're going to get into graphing. Alright, so one way you can graph is by plugging x's in to your equation and giving you y's. Alright, so if we have this equation y equals x squared, and then we wanted to find the point that corresponds with when x is -3, well, we could just plug that in and would get -3 squared or 9. All right, so that's one way that you could graph, and you could take that -3 and 9 would give us our ordered pair, so like -3, 9, and we could graph that up in there, and it would give us a point about right there. Okay, and we could continue doing that. So -2 squared will give us 4. -1 squared will give us 1, 0, 1, 4, and 9. And we could come up with all of those points, and we could graph that way, and it would be great. So -2, 4 is right there. -1, 1, 0, 0, 1, 1. And so forth. Okay, and we'd connect all those dots, and we could see our nice parabola color, or not color, shape, that we've been talking about in our last lesson. Okay, so when you graph, I'm going to ask you to at least do 5 points. So like these 5 points, you do not need to do more than that, although sometimes it makes it a lot nicer, or it looks nicer, if you do as many points as possible. And I'm going to ask you to always take that parabola to go all the way outside of the graph. Okay? And again, we put these little arrows on the ends to tell us that it's not just stopping at that point, it keeps going forever. All right? So that is one way that you can graph. But if we look at B, it's a little different. So like here, if we wanted to plug in a -1, a -1 here and for here, our equations get a little more difficult, and having to like plug this into your calculator every single time kind of would take you a while. Okay, but you could take this part and plug that into your calculator, and you would end up getting 8. And there's nothing wrong with that. Okay, but the idea for today is to try and figure out some sort of pattern that we can notice so that we can graph a little easier. Okay, so here we could plot that, -1, 8, which is right here. Okay, I'd like you to pause and finish B and do C as well. Okay, all right, so pause. All right, so we'll just fill in the rest. Hopefully you had time to give that a try. I think it's a good skill in an emergency. If you forget kind of like the easier way to do it, you could always plug stuff in and give yourself points. Okay, but I mean, in this situation, one thing is that I give you the x values that what we'll want to graph, if that makes sense. Okay, you could have the graph over here or something, and you'll start trying points here, and you're like, well, these points are like totally big, or I can't graph those. So that's one of the nice things about what we're covering is this is going to make graphing easier for you in the long run. Okay, so hopefully you finish this out. You got 8, and then here we have 3 and 0, -1, 0, 3, and 8. Okay, you kind of see that we have this like pattern that repeats itself after it gets to what happens to be is the vertex. And we know that parabolas are symmetric, and that's why we have the 0s and then the 3s and then the 8s, because these graphs are symmetric. All right, so we'll plot these. Actually, I think just to kind of save some time, we're just going to do this. Okay, so you would plot those points, and you would see that we have another parabola, and it looks great. Okay, we can do the same for this one. Hopefully you gave C a try. Again, these numbers are kind of getting bigger. Again, if you started at like a -4, you'd end up getting a really big number. So here we'd get 11, 6, 3, 2, 3, 6, and 11. Again, it's symmetric. And then we'll just plot this, just using my magic thing. It looks like we've got our vertex is 5, 2, 5, 2. Okay. Perfect. Okay, and this one kind of goes outside of the graph. All right, so I didn't mean to have that be there, but pretend like I didn't write that there at the bottom. Okay, it says, at the bottom it says, look at the table you filled out. Make an additional column for the rate of change. Compare the 3 examples, and what do you notice about the rate of change? All right, so to find the rate of change is we just do the difference between our 2 y values, okay? I mean, the rate of change is like your rise over run, right? So if we were to do our run, this is always going to be 1. So we're just going to kind of look at the y's and try and figure out what is the rate of change. So the difference between 4 and 9, so 4 minus 9, that would give us a negative 5. 1 minus 4, that gives us a negative 3. 0 minus 1, that gives us a negative 1. 1 minus 0 gives you 1. 4 minus 1 gives you 3. 5 minus 4 gives you 5. Okay, so we have this, again, we kind of have this symmetric thing going on. And this is the rate of change. Rate of change. Okay, and we're going to want to see how it compares with B and C. Because I mean, these values are a lot different than the ones we did above. Okay, so if we were to find the rate of change here, you may want to pause and give us a try and see if what you notice. So, but here we'd find the difference here would be 3 minus 8 would be negative 5. 0 minus 3 is negative 3. Negative 1 minus 0 is negative 1. 0 minus a negative gives a positive. Positive 1. 3 minus 0 is 3. And 8 minus 3 is 5. Well, wait a minute. What do you notice about the rate of change for A and B? They're the same. So let's look at C. Maybe they're all the same. Let's see. 6 minus 1 is negative 5. And this would give us a negative 3. This would give us a negative 1. 1, 3, and 5. Okay? So it looks like they all have the same rate of change. Okay? They have the same slope between each point. Okay? So it looks like if we were to go here and look at this and would say, well, the rate of change, it's always going to go over 1. Maybe I'll do a different color. We go over 1, and then we go up. We go over, we go up 3, and then 5. Okay, that's the pattern that we found here, 1, 3, 5. Does it apply to all of these? It sure does. Over 1, up 1. Over 1, up 3. Over 1, up 5. Over 1, up 1. Over 1, up 3. Over 1, up 5. Okay, so if we can find this vertex, we can use this pattern. We can go over 1, up 1, over 1, up 3, over 1, up 5. 1, 3, 5. Okay, well, let's see if this always applies for everything. Okay, so I already graphed these parabolas. If we were to go over here, we'd go over 1, up 1, over 1, up 3, over 1, no, this isn't working. Okay, so let's see what's the difference. What would be the rate of change? Okay, so if we did 6 minus 16, that gives us negative 10. And then here, 0 minus 6 gives us negative 6. Negative 2 minus 0 gives you negative 2. 0 minus a negative 2 gives you 2. This would give us 6 and 10. So we still have this kind of pattern going on, but what do you notice about the difference between these rate of changes? Before it was 1, 3, 5. Now it's 2, 6, 10. We go over 1, up 2, over 1 up 6, over 1 up 10. Okay, so what's the difference? What do you have to do to get from 135 to 2, 6, 10? Kind of think about that. Let's see if this one applies the same. So if we were to do over 1, or I guess we could just do it here. Difference here would be negative 10, negative 6, negative 2, 2, 6, and 10. So it has the same growth pattern as D. Okay, so what do you notice different between D and E? What do they have in common? And also, what do they have? What the difference between D, E, and these three? Okay. Okay. So hopefully you're realizing that the difference here is this had to be multiplied by 2, and here we have a 2. This was multiplied by 2, compared to like 135. And here we have 2. Okay, let's see what would happen with 3. What would these values need to be? What would be our growth pattern if A was equal to 3? So here, let's just figure this out. So here that would give us a negative 15. This would give us a negative 9. And this would give us a negative 3. 3, 9, and 15. Okay, so 3, 9, 15. Over 1 up 3, over 1 up 9, over 1 up 15. Okay, so it seems like there is a relationship between the growth rate and what A is. Okay, and we're going to talk about that. Okay, so here A, B, and C all have the same rate of change. D and E have the same rate of change. Okay, this is when A was 1. This is when A is 2. And F is when A is equal to 3. Okay, so A value depends on our growth rate. And what do you think the center of that would be? The center of the rate of change? Well, that would be the vertex. Okay, so like here would be the rate of change. It is kind of like the center, it's the vertex. Okay, so basically, in order to graph a parabola, you need two things. You need the vertex and you need the rate of change. And the rate of change is based on A. And the pattern that we've come up with is that we'll always go over 1, and then we will go up, or it can be down, depending on A. So we'll go up or down 1 times A. And then we'll do over 1, up or down 3A. Over 1, up or down 5A. And this would continue to go on. 1, 3, 5, 7, 9, 11. Okay, it's just all odd numbers. So this is kind of like our pattern here, is that we would go over 1 and we'd go up 1. We'll go over 1, up 3. Over 1, up 5. And depending on A, if A is 1, then it would just be 1, 3, 5. If A is 2, then we found out that we would go 2, 6, 10. And that's just 1 times 2, 3 times 2, and 5 times 2. All right, so, okay, so let's just do some examples and see what we can come up with. Okay, so again, we need to have the vertex, and the rest of our unit, we're going to be focusing on trying to find the vertex in different forms. Okay, but here we're just going to start by, I'll give you the vertex, and then we want to find the growth pattern. So here we have our vertex. We can plot that straight up. So 2, negative 4, sorry. And then we'd want to find the growth pattern. Well, again, we'd want to find out what A is. Here, A is the number in front of the coefficient, or in front of the x squared. A will always be, let me write that on the side. A is always the leading coefficient. Okay, so here A is 1. So we would use our pattern 1A, 3A, 5A. Since A is 1, we'd plug those in, we'd just get 1, 3, 5. So we'll go over 1, we'll always go over 1, and then we'll go up whatever 1A is. So 1A is 1. Over 1, up 3, over 1, up 5. Okay, and then since parabolas are symmetric, we can do it on the other side as well. Over 1, up 1, over 1, up 3, over 1, up 5. And then we can connect the dots, and we're set to go. Okay, so let's look at B. This one's a little different. This is in a different form, but still our leading coefficient will be A. So here A is a negative 2. And we'll do 1A. Well, that's 1 times negative 2. That gives us a negative 2. 3A, that will give us a negative 6. 5A would give us a negative 10. Okay, so now we just plot our vertex and then use our growth pattern. So negative 1, 8, which is right here. And we'll go over 1, down 2. Over 1, down 6. Over 1, down 10, which is outside, so we wouldn't need to do that point. And then we do it symmetrically on the other side as well. And then we'll connect our dots. Again, just do your best. Okay. All right. Pause and see if you can do C and D. And then we will do a quick review on finding key features. All right, so if we gave this a try, the vertex here is 5, negative 3, so we go to 5 and negative 3, which is right here. And then we need to find our growth pattern. So here A is, again, it's always your leading coefficient, so A is 3. So we'd do 1A, 3A, 5A. So 1 times 3 is 3, 3 times 3 is 9, 5 times 3 is 15. And now we'll go over 1, up 3, over 1, up 9, which is, well, I'll just put it there so we have 5 points. And we've got it. So we connect those dots, do the best we can. Okay. All right, and then D, here we've got 4, 4 is our vertex, so that's right here. And here our A value is a leading coefficient, so that would be a negative 1. So we'd do 1A, 3A, 5A. That would give us a negative 1, a negative 3, and a negative 5. Okay, so we go over 1, down 1, over 1, down 3, over 1, down 5. And we do it on both sides. All right, so let's do some of these key features to make sure we keep, have practice on that so we don't forget. All right, so our x-intercept for here, these would be our x-intercepts. So we would have negative 3, 0, and 1, 0. Y-intercept, here is where it crosses the y-axis. That would be 0, 6. The axis of symmetry is this vertical line that cuts the parabola equally in half. So that would be x equals negative 1. Oh my, vertex is missing. So vertex should be in here. So the vertex here would be negative 1, 8. The maximum or minimum value would be a max, and its value would be 8. Domain would be all real numbers. Okay, again, we can also write it like this or like this. Range is all y values, so we'd start at the lowest and go up. So it'd start at negative infinity all the way up to 8. So negative infinity to 8, and it would include that, so we'd want that bracket. We could also write it as y is greater than or sorry, less than or equal to 8. Increasing, so where the slope is increasing, our rate of change is positive. So it would be that left side would go from negative infinity to -1, or we could say all x values less than -1. And decreasing would go from -1 to infinity, or where x is greater than -1, and the direction of opening is down. All right, so pause and give D a try, just fill in those key features, and we'll be set. So here are x-intercepts, again, are right here and right here. So we'd have would have 2, 0, and 6, 0. Y-intercept, okay. So here we can't see it yet, but in the future we'll talk about how we can find the y-intercept, okay. One thing you can always do is that we know if it's the y-intercept, we know that x is going to be 0. And if we know that x is equal to 0, then we could plug in 0, or x for 0, and we'd end up getting y is equal to like 0 plus 0 minus 5. So we'd end up getting -5. Although that graph does not match. My equation might be wrong. So let's just ignore that for now. I need to double check that. I must have gotten rid of or changed the equation. So we'll do this later. Okay. All right, axis of symmetry. Again, what cuts it in half? So that would be x equals 4. Vertex, I don't know why that disappeared. Vertex here would be 4, 4. We already have that. Maybe that's why I didn't have it. It's because we already have it. Okay. The vertex is a maximum, and its value would be 4. The domain would be all real numbers, or the other two ways you can write it that I did above. Range is all y values, so it would start at -infinity and go all the way up to 4. Or we could say all y values less than or equal to 4. Increasing is, for this one, would be the left side. So that would be from -infinity to 4. Or you could say all x values less than 4. And then decreasing would be 4 to infinity, or all x values greater than 4. And the direction of opening would be down. All right, sorry about that mistake. So if you have any questions, let me know, and we'll see you later.